with Patrick Dube, ReNEW, talking about the ReNEW Water project, and he's going to bring it home strong.
All right. So my name is Patrick Dube. I'm with the Water Environment Federation, and going to talk a little bit today about a new project we have, the ReNEW Water project, and it's discussing resource recovery in the wastewater industry. So a little different from the talk so far today. A little background to kind of frame why the wastewater industry got interested in resource recovery. It really started about 2013, decided to kind of start to change the mindset in the sector from thinking of wastewater as a waste to wastewater as a resource. You know, there's so much potential in wastewater, whether it's through the clean water, whether it's through the nutrients available or the energy. And so in 2013, we actually started this in a seemingly small way, but I think it's paid big dividends by trying to promote the change of the nomenclature from a wastewater treatment plant to a water resource recovery facility. So that's something we've been trying to promote, and it's begun to kind of, just kind of change the mindset and kind of incept into people's heads. And this is resource recovery is a core value of the Water Environment Federation. It's in our strategic objectives and critical goals, and it's something that we try and promote through everything that we do, not only just this project. So this is the ReNEW Water project, and like I mentioned, all of the different resources that wastewater contains, water, energy, nitrogen, phosphorus, and biosolids, we are trying to set a baseline for the industry and then use that in the future going forward to then set goals. So we took a mass balance approach to this. Essentially draw a box around a water resource recovery facility. You have what's coming in, you have what's leaving, and then essentially that's the percent recovery. So we're looking at the percent that we're recovering for water, nitrogen, phosphorus, biosolids, and energy. We started this with certain partners and a project team of consultants, the Water Research Foundation, Water Reuse, NACWA, Aqua, and Rousseau. And they got together and started this project. And the data collection came from two different sources. It came from available data sets that were already widely accumulated, I guess, and then a water resource recovery facility survey. And these two combined to set our baseline goals. So the baseline, here are the baseline numbers for all of the resources that we are measuring. We found that the industry, on average, is recovering 7% of the available water, about 41% of the potential energy recovery, 11% of nitrogen, 21% of phosphorus, and 51% of biosolids. So this was done, we surveyed 109 different water resource recovery facilities around the country. We surveyed different sizes from the 0 to 5 range to the upwards of 50 MGD, and tried to get a good representation of the country as well to kind of get hopefully a full picture of the sector. So now let's kind of dig into the phosphorus results. When we're talking recovered and not recovered, we considered, or the study considered recovered phosphorus as 3 different sources. From the water effluent, that was water that was reused for irrigation purposes, so not potable reuse or anything like that. From the biosolids, any fertilizer production, so this is struvite, anything precipitated out. Land application was also considered recovered, and landfill was, of course, not recovered nutrients. So here are the results for phosphorus in the wastewater. In total, from the survey, from both the data and the survey, we found that there's about 319 100,000 metric tons per year of potential phosphorus to be recovered. And as I mentioned earlier, 21% of that is currently covered in the industry. Most of that is done through biosolids, 19%. And then there's a small portion that is turned into fertilizers and used for crop irrigation. And the not recovered phosphorus is about 79%, and found that most of the water from water resource recovery facilities is just cleaned and disposed back to the environment. Some biosolids is landfilled. That would be not considered reuse, and then about 7% was other. So when we kind of break down the actual information available, they broke it down by state. Here's the total potential phosphorus in dry metric tons per state. So the amount that could potentially be recovered by each state. So you see, no surprise, the bigger states have more readily available phosphorus in their water resource recovery facilities. And here's an interesting graph. On a state-by-state basis, the amount of wastewater this is just removed and not recovered. You can see states in regions that have phosphorus issues obviously do a much better job of removal. States like in the Chesapeake region, like Maryland and DC, Pennsylvania, they do a pretty good job, very good job of removal. And then in the Great Lakes regions, the Michigans, Wisconsins, they also do a very good job. Whereas you have a state like Colorado, which doesn't have currently any large-scale phosphorus issues, they don't do much removal in their wastewater. And this is just kind of framing that data into the percent removal versus percent not removal. So you see there's a lot of potential for more removal of phosphorus in wastewater. The heavy lifting is done by a very handful of states. And now we get into the recovered data, and I think the takeaway from this is there's a lot more orange than there is blue, and blue is not recovered. So there is a lot of potential in the industry to recover more phosphorus from our water resource recovery facilities. And again, I think if you want to look at where there are gaps and where we can achieve this a greater amount of recovery from phosphorus, you have to look at the bigger states. They have to do a better job, the Californias, the New Yorks, the Floridas, because these 5 or 6 states, they represent a much larger proportion of the amount of phosphorus that could be recovered from these water resource recovery facilities. So if we can get some large-scale change in the bigger states, we could have a much greater jump in that 41% level. And here we have, again, just not recovered versus recovered biosolids and phosphorus. And here's a breakdown of the amount of where the recovery is happening. So these orange lines are the phosphorus that's recovered in biosolids. And you can see most of the phosphorus is done, recovered through the biosolids. And there's a very little amount of irrigation. It's really only happening in California and Florida, and very little done in the fertilizers. So if we want to improve our phosphorus recovery from water resource recovery facilities, there's a lot of potential in the biosolids areas because only about half is recovered right now. And we need to improve our phosphorus recovery through mechanisms like irrigation, things like that. And this is just a mass balance kind of showing the confirmation of the data. So these values were released, the baseline values were released at WEF. And the plan for this program going forward is to kind of next, so we have the baseline, now we need to set goals for the industry. We need to come together and find, I think the next step will be to kind of incorporate circular economy type of ideas and then set goals every 2 years and come back and write reports every 2 years and report those out and see how the industry is improving on those baseline numbers. So the goal is to increase awareness about resource recovery in the water, in the wastewater sector, and improve on that every year for the next 10 years. And those reports will be coming out every 2 years starting in 2020. So thank you. If you have any questions, please let me know.
Questions for Patrick, huh?
Sophie Mancuso. Oh, okay. Sophie Mancuso. I was just curious, because you do a survey and you only have a small portion of people responding, how could you improve those statistics to not have a bias in who provides the data?
I mean, we're always open to more utilities doing that. I think that 109 utilities actually represented about 22% of the entire industry. So it was excuse me? I believe by volume, yes. Yeah.
I have a project team question.
Okay.
So how do you have that organized by sector? You have a nitrogen specialist, an energy specialist, or lead? And if so, who's the phosphorus lead?
I don't believe they separated it out by leads. It was kind of more of a holistic approach, I think. So, yeah, there were, because the numbers were, it was really a kind of a task of looking at the data sources that were available and then the surveys and bringing that in. And as you see, they kept it pretty bird's eye view. They kept it, a fence line around the utilities. Keep it like that.
Yeah, just a question of clarification. You had a slide, and I saw 100%, and I think I saw DC below it. What is 100%?
Oh, that was the
Yeah. What is this?
removal. This is the amount of removal that DC does for their wastewater treatment.
100%.
Yeah. That's from the wastewater. Yes. Yes.
Yeah, I think, sorry, Patrick, as part of this work, I think the perception challenge here is that this is the volume of water that has phosphorus removal applied to it. So all of DC water is treated at one site, and that one site has a phosphorus limit, and they do chemical phosphorus removal of the water. They're not removing 100% of the peat from the water.
Yeah.
I live on the Anacostia River, and I would, yeah. So you're just talking about the stuff that goes down to the wastewater treatment plant and no other releases.
Yeah, this is all publicly owned utility wastewater statistics. I mean, WEF is
Yeah.
an organization that's who this is.
Okay.
Matt, this is a very good presentation. Thank you for doing that. I've just noticed, and maybe tying back to Jim's point and Bruce's point earlier in the opening session in terms of the impact from municipal sector, which probably in the phosphorus cycle it means 1%, but there's a 55% here from the ag and maybe larger communities. I'm just wondering if there are lessons here that might be useful for the ag community to begin a baseline study and see how they might benchmark each other and perhaps try to reduce. It gets back to the phosphorus challenge in a way. So I was just wondering whether there's some lessons here that could be shared with the ag community.
Yeah, I think it's always, the goal of this was to be able to put out some numbers that are quantifiable and show, we're starting here and we want to get to here. It's kind of similar to the phosphorus challenge. You need to set smart goals. You need to set commitments that you can actually quantify. So it'd be great for the ag industry to also look into and compare to, yeah.
I'm just wondering, how could we remove almost 100% of phosphorus from any kind of water, unless it's a DI water?
So this isn't amount of phosphorus removed. It's percent of water that has phosphorus removal treatment done to it. Does that make sense? So this is a volume or percent of wastewater in DC that has some type of phosphorus removal treatment on it. And that phosphorus removal treatment might not remove 100% of the phosphorus. Yeah.
This doesn't differentiate between DC, which has a 0.17 milligram per liter discharge permit on an annual rolling average, and I'm trying to think of a good example, Michigan, which primarily has 1 milligram per liter discharge. There's no differentiation in terms of the level of phosphorus treatment, nor the type between biological and chemical. So this was really driven at a different metric than focusing on mass of phosphorus.
And same for the entire state of Vermont.
Yeah, so Vermont as a state has phosphorus limits on their wastewater systems, period. That's really what this is showing.
And we're a small state like DC, where there were fewer wastewater treatment plants compared to New Jersey and New York.
Well,
So it makes it easier to meet the 100% number like the DC example.
well, I would argue the opposite, Vermont, because it had lots of small plants, it's not easier.
They have lower limits, and so all
They just have water quality issues. There's a couple other things here, so we challenge your Colorado state in a little bit. The state of Colorado is going to statewide P limits because there are significant water quality issues in Colorado. Utah is heading to statewide P limits, period. Ohio is studying it. Illinois is going statewide limits. So there's a lot of things in here that are shifting, but this is, I think, a great set of data to determine where we are today and do this in 10 years and compare the results and see kind of what that net result is. Sorry to steal your
No,
thunder a
that's
little
fine.
bit.
I appreciate it. I appreciate it.
The one question I posed this when the study was being done that, I think it just wasn't part of the scope of the study that hasn't been done is connecting the biosolids application into some of the watershed modeling discussion from this morning. And then secondarily, phosphorus that is precipitated out chemically and ends up in the biosolids is not the same as phosphorus that is assimilated into the organism in the biosolids, which is not the same as the phosphorus that's precipitated as struvite or other compounds and is applied to the land. P is not P. This is purely done on a mass basis. You saw the formula, very simple as a starting point, but the next level to me has to look at how is it applied, where is it applied, what is it applied, what form is it in when it's applied, because not all P.
Yeah, so that leads into a clarifying question I had about. Oh, thank you. Oh, sorry.
Well, that does lead to the concept of water extractable phosphorus in the form of the phosphorus and how it's released from the biosolids, whether it is released or not, and to what degree. The question I had is, so follow-up statistics. So now there's a baseline. I assume the same team and the same process are being proposed for these biennial updates. Is that accurate? And what if there are issues found with the baseline? How will that be updated for good comparisons going forward? In other words, often baselines later on you find out in some projects that it's got some things to skew. So do you readjust baseline based on new data, and then in order to have accurate comparisons to updates?
Yeah, I assume any of those challenges they'll be met, and I think because it's kind of evolving, they're continuing to get more input and find new data sets. If anybody has new data sets or want to provide them, please provide them to me, and I'll get them to the team. More expansive data sets, because this was all just kind of publicly available stuff and did have some limitations. But I think the goal is to every 2 years kind of take a look at it and put out a new report and kind of keep it up for the industry.
So I had a clarifying question on the metal salt addition, or the chemical precipitation removal to meet discharge limits. So if a wastewater treatment plant applies alum or ferric chloride and takes that precipitant to a landfill, obviously that's not recovered phosphorus. But if if another wastewater treatment plant takes that precipitant and mixes it with the biosolids, and that's land applied, does that count as recovered phosphorus or not
Yeah,
recovered?
yeah, that's recovered. Because again, we're keeping it, as long as it stays in the fence, that's kind of where we're looking at it.
Further questions about this interesting study?
And this report is available on the WEF website. If you just search WEF Resource Recovery Survey, I think you should be able to find it.
Thank you, Patrick.